Okay, good morning, grade 10s. I had a question about confidence intervals, in particular the table here. So I want to get into that first, and then I'm going to go through one of the examples that we had in our lesson as well. So if I want to know a 90% confidence level and what z-score is associated with that, what I need to know is the middle 90% of the curve. So let's say that, for example, everything inside here covers 90% of the curve, then I'm going to be interested in the z-scores that are associated with these kind of endpoints here. Okay, so if I have 90% of the curve in the middle, that also means that there's 5% left over on each side. And this is what's going to help us develop what z-scores we're going to need. Okay, so in the back of the book, on page 480 and 481, there's a big table and it's showing all of the probabilities, and it also has the z-scores labeled across the top and the side there. So I think it goes, the first decimal place is on the left side, the second decimal place is on the right side, or sorry, on the top part, and you kind of find out where they intersect. So if I were to now look up 5%, in the table, we're looking for the closest value to 0.05 inside the table. Okay, and what we're going to end up finding is that at positive or negative 1.64, you'll find 0.0505. Okay, so that's pretty close to 5%. And we'll also find that 1.65 is 0.495. So both of these were equally close to our 5% on each side. Okay, so you could have also looked up, 95%. That would give you the positive version. Just 5% will give you the negative version. So just kind of the middle of these two, because they're both equally distant to what we're looking for. We've got positive and negative 1.645. Okay, so that's all gathered from the table on page 480 and 481. So if we did this again for 95%, okay, so here's our normal distribution curve. Okay, so this curve is always centered at our mean, and if we're looking at a normal distribution, our median and mean are going to represent the same value. So for 95% confidence level, we're working our way a little bit further out. So I'm just kind of estimating here that this is 95% of the curve. What does that leave over or leave out? There's going to be 2.5% here, 2.5% here. So if we look for in our table the closest value to 0.025 or 0.975, we can actually find an exact value for this one. So the negative side would be negative 1.96, and this would be 1.96. So these two kind of endpoints where 95% is going to be between them would be plus or minus 1.96. Okay, so the exact value was found there. And our last one, we do it one more time. For a 99% confidence level. Okay, so we're leaving just a tiny bit left over on each side. So this is going to be 0.5% on each side because there's only 1% left. So we're looking at 0.00. Actually, Yeah. This is going to be 0.5%. Okay, but the values associated with that in the table would be looking for 0.005 and 0.995. So try to find the closest value to these two. And kind of like the first one, we can't find an exact value there, but we can find something that's a little bit to the left and a little bit to the right. So if we looked up 0.005, the closest we could get is 0.0051 and 0.0049, and this was negative 2.57, and this was negative 2.58. So similarly, here if we look this one up, we'd find something slightly above and below, and they would match these same two z-scores as well. So this one we would have plus or minus 2.575. Okay, so I'm adding that extra half in the first and third confidence level here, just to kind of get it in the middle of the two closest values. So 95% confidence interval, that one was exact from our table, and the other two we had to kind of estimate. So just to kind of go over it again, we're looking at the middle 90%, the middle 95%, the middle 99%. We use these kind of endpoints here to help develop or to help find our z-scores. All right, let's get into example 2 here. So in example 2, this one's talking about voter turnout. So 53% of the vote went for a certain guy. 1,500 people voted, so we can plug in our values here. So this one, if I remember correctly, I think it also mentioned something about 19 out of 20 times. I think that's what it is. I will have to look back at it. But it mentioned either something that happened 19 out of 20 times, or it might have mentioned 95% in the question as well. I probably should have written that down. But it was talking about this z-score. Okay, so you can flip back to it to have that in this question here. So you can always go back to the page 480, 481. But really we're going to use these three. I don't think we really focus in on too many others. These are the three main ones we'll look at for this section. Okay, so our z-score, we have positive and negative 1.96, that's not a 6, times the square root, percentage of people that did vote for him, times the percentage of people who didn't, which is going to 1 minus 53% will be 47%, and we got a total of 1,500. So let's calculate this here. So I'm going to do everything in the square root first, and we'll use that to develop our margin of error. 0.53. Okay, now I'm going to do it all at once here and multiply that in, and you end up with plus or minus 0.02526. Okay, so that means we have a margin of error of 2.526%. Okay, so that would be the margin of error The confidence level, I think, was B part. Okay, and this is using our margin of error to kind of add and subtract from our value here. Okay, so if I take 53% plus 2.526. So we're going to add and subtract it. I don't really need the calculator here, but we got 55.2. And if we subtract it, okay, so what does this all mean, tying it all together here? We're 95% confident that the vote should be between 50.4 to 55% for this candidate in this election. Okay, so keep asking some questions. There's a second margin of error formula that's later in the note. The key thing, that one's talking about means, so if you see any problem that's talking about giving you any value associated with the mean, you have to use that one. This one will be used the rest of the time. All right, so keep sending the questions in. Have a good day.